Right now, as you're watching this video, an invisible force is ripping particles from our atmosphere and hurling them into space at incredible speeds. The most surprising part, if this force were just a bit stronger, life on Earth simply wouldn't exist. Imagine a secret so subtle yet so powerful that it went unnoticed for generations. Get ready to travel through the mysteries of the secret force field that protects our planet. And hold on, before this invisible shield whisks you away into the cosmos, stay with me until the end because this story is about to blow your mind. Think of Earth as a cosmic fortress, surrounded by protective layers that make life possible. The first barrier is gravity. It holds onto our atmosphere, preventing it from floating away into the universe like a helium balloon in the wind. Without this shield, all the air we breathe would be ripped away in the blink of an eye. The second shield is even more fascinating: Earth's magnetic field. Invisible to our eyes, it's in a constant battle, deflecting deadly solar particles speeding toward us at nearly 1.2 million miles per hour. Without this, we'd be like Mars, a dry desert stripped clean by the solar wind. But something always intrigued scientists. For decades over the Earth's poles, atmospheric particles were seen escaping at supersonic speeds, yet strangely cold. It wasn't the sun pulling them, nor magnetism, but a phantom force, subtle and mysterious. These hydrogen and oxygen particles behaved in ways no model could explain. It was as if a cosmic vacuum slowly sucked our atmosphere away, threatening our survival every second. The big question loomed: what exactly was happening at this invisible boundary? We knew something was protecting us, but it also allowed a carefully controlled leak into space, a precarious balance unnoticed by most people on the planet. Until finally, modern technologies brought answers to questions that had been locked away for more than half a century. And now, with this investigation underway, we dive into one of the greatest scientific adventures of our time: the hunt for Earth's hidden electric field, a fundamental secret to our very survival. For a long time, humanity believed these two shields, gravity and magnetism, were all we needed to keep Earth habitable. But small anomalies in the polar regions shattered that comfortable belief, raising intriguing doubts about our understanding of our planet. It was as if, in a seemingly impregnable castle, a secret door remained slightly open. Earth's atmosphere, though it seems stable, is constantly moving and transforming. Streams of particles flow into space all the time, especially in the polar regions, where solar winds interact directly with the top of our protective layer. Researchers began to notice that these escapes didn't match up with traditional models of atmospheric loss, pointing toward the involvement of an as-yet unknown force. The problem was, nothing we knew could explain the signs. What kept the particles cold, even as they were expelled at extreme speeds? Scientists wondered, was there a third line of defense, hidden and mysterious, operating overhead? The stage was set for a revolution in our understanding of planetary survival. For 60 years, the mystery persisted. Scientists worldwide pored over partial data, suspecting that some subtle force governed atmospheric loss at the poles. It was like searching for the flutter of a butterfly's wings in a hurricane of cosmic variables. The real breakthrough came in 2016, when the Venus Express probe revealed a giant electric field at Venus, 10 volts, 5 times stronger than anyone thought possible on another planet. Immediately, comparisons flared. If Venus, so similar to Earth, had such a field, why not search for something similar here? The revelation at Venus was a shock. That massive force was sucking away the planet's atmosphere, turning oceans into interstellar dust. Earth's sister planet was, in essence, a victim of its own electric field, an invisible villain draining away everything that could have supported life. The question that galvanized scientists was almost frightening. What if Earth also had an electric field, but just the right strength? What if the difference between our planet being a blue oasis or a barren rock was only a tiny fraction of a volt? The hunt became a matter of cosmic life or death. Multidisciplinary teams simulated scenarios, tested theories, and ran up against technological barriers they'd never faced before. They needed real data, and for that, it took courage, creativity, and a touch of scientific madness. That's when Project Endurance was born, an extreme mission, ready to defy the impossible and bring back answers that had lived only in the imagination for decades. The stage was set for one of the boldest scientific experiments in recent history. With the discovery at Venus, scientists realized that planetary electric fields could be fatal or essential for life. The difference between a vibrant blue world and a scorched desert might come down to an almost invisible tweak in the forces that govern a planet's atmosphere. Laboratories and observatories everywhere buzzed with hypotheses and simulations, trying to quantify and model this elusive force on Earth. The challenge was monumental. The measurements required instruments sensitive enough to register tiny changes, fighting off both natural and artificial interference. International collaborations formed, satellite data was shared, and more sophisticated sensors were developed. Each step toward solving the mystery was marked by heated debates, classic theory revisions, and more questions with every partial answer. The search became more than scientific curiosity. It was an attempt to answer the most fundamental question of all. Why does Earth protect us so well? Scientists became explorers of a new frontier, determined to reveal the hidden machinery that makes our planet so unique in the cosmos. Detecting Earth's electric field was like trying to hear a whisper in the middle of a volcanic eruption. The team needed absurdly sensitive instruments and, above all, the perfect scenario, a place where cosmic noise was at a minimum and the best chance existed to find the electric signature. Svalbard, Norway, near the North Pole, was chosen as the battleground. In May 2022, a suborbital rocket from Project Endurance soared through the Arctic skies, carrying equipment capable of measuring the tiniest variations in electric potential right in Earth's ionosphere. For almost 20 historic minutes, the rocket gathered precious data, flying through atmospheric layers still barely explored. Scientists around the world watched anxiously, knowing that any discovery here would have enormous consequences. The eureka moment didn't take long. The instruments finally detected a potential difference of 0.55 volts, less than a watch battery, but enough to rearrange everything we thought we knew about Earth's atmosphere. Half a volt was all that separated our survival from the cosmic void. Every piece of data was analyzed with obsessive precision. The confirmation of Earth's electric field proved the suspicion. There's a dynamic balance, controlled by an ambipolar field, that decides who stays and who leaves the planet. The most surprising revelation was realizing just how much we depend on this nearly imperceptible force. One tiny adjustment, a small misstep, and Earth's fate could have been just like Venus. A dry, sterile place, stripped by a relentless solar wind. The mood at the Svalbard launch base was one of suspense and awe. Engineers and researchers knew that any failure could have sent the mission back to square one, delaying answers for years or even decades. Preparations were meticulous. Every sensor was calibrated, every step analyzed and double-checked with no margin for error. During the rocket's brief but intense passage through the ionosphere, the ground team followed every live transmission, holding their breath as the data streamed down from the polar sky. It was like witnessing a perfect collaboration between human technology and the mysteries of nature, a symphony of numbers, fields, charges, and oscillations. When detection of the 0.55-volt electric field was finally confirmed, the psychological impact on the team was immediate. There was euphoria, relief, and a near reverence for being part of a discovery that would make history. The coming months would be filled with analysis, reviews, and publications, but the certainty was clear. They'd unlocked a door that had been invisible throughout the history of planetary science. Half a volt might seem insignificant, but on a planetary scale, it's a colossal force. For the lightest particles like hydrogen, this field creates an upward push up to 10 times stronger than gravity, literally flinging them into the vastness of space. When solar radiation hits the upper layers of our atmosphere, it splits atoms into electrons and ions. Electrons, being so light, escape easily, but the ions, much heavier, want to fall back down. The electric field links the two, like an invisible cable between a helium balloon and a powerful anchor. This mechanism creates a cosmic conveyor belt. Particles rise, are accelerated into space, but at controlled speeds and quantities. It's a delicate balancing act, something that keeps the atmosphere from being torn away completely by the solar wind. The magic is in the details. If our field were just a bit stronger, enough to match the value found on Venus, everything would change for the worse. We'd lose water, oxygen, and quickly the rest of our atmosphere. The vital difference is that fine adjustment. Earth's ambipolar field is exactly as strong as it needs to be. Not too much, so we don't lose everything, and not too little, so it can still work. It's a perfect balance between retention and loss, something we're only now starting to understand. This puts everything in perspective. We're not just lucky to have what we have, but to keep it. Our atmosphere is a rare gift in the universe, shielded by a balance so fragile that it literally depends on fractions of a volt. Imagine billions of particles being launched, accelerated, and ferried away every day, at a scale imperceptible to our senses. The electric field works in secret, selecting which particles escape, like a cosmic doorman controlling the in and out traffic at an immense celestial ballroom. Without this mechanism, our planet could have lost all its water billions of years ago. This conveyor belt effect highlights just how much equilibrium depends on often ignored forces. Satellites and experiments continue to capture the nuances of this process, indicating that even small changes in these interactions could have long-term environmental and climatic impacts. There's an elegance and a risk to this balance that inspires both awe and humility. Our own bodies, plants, the oceans, everything lives and breathes thanks to this delicate dance of electrons and ions overhead. It's a silent reminder that, in the universe, the invisible can be more vital than the visible, and life is supported not by certainties, but by the choreography of almost impossible probabilities. This discovery changed everything about how we understand planetary habitability. It's not enough for a planet to be in the right zone near its star. It needs an electric field of just the right intensity to hold on to water and support life. Every planet with an atmosphere likely has its own electric field, its personal access code for life. Many worlds might be out of the running, not because they lack water, but because they lose it too quickly to the interstellar void. For the search for extraterrestrial life, this is a game changer. Now we know we need to look not just for Earth-like planets, but for signs of electric fields set to just the right value. The odds of finding a real habitable twin just got lower, but our understanding got deeper. It's almost poetic to realize that human existence, our entire history, culture, and dreams, depends on a thin cosmic electric wire. Half a volt, the difference between a blue paradise and an uninhabitable desert. It's humbling. We live on the slimmest of margins, in a balance so delicate between cosmic forces that any change could turn everything to dust. It's a lesson in cosmic humility and existential gratitude. Next time you look up at the sky, remember, you're guarded by 3 invisible shields, the outcome of billions of years of evolution. Without them, not even humanity's greatest dreams could survive out in the cold of space. This realization has redefined the parameters of astrobiology and habitable exoplanet research. Now, along with searching for liquid water and mild temperatures, we look for the right electric fields, a new filter for the already tough quest for life beyond Earth. Each electric field could be the cosmic guardian of its reality. Even the atmospheres of gas giants, mysterious moons like Titan, and distant worlds with exotic clouds are being reinterpreted with this new understanding. Science now sees that creating and preserving complex atmospheres is much harder and rarer than we once thought. The research pushes forward, fueled by the prospect of rewriting whole textbooks of planetary science. Maybe most mind-blowing of all is the idea that, in the universe, the line between survival and extinction is drawn by tiny, nearly imperceptible forces, as if the cosmos is a place of narrow doors, where existence is granted only to those who unknowingly unlock the secrets of invisible fields. Earth's ambipolar field was hidden for decades, but its discovery shows the true wonder of a universe where small details decide fates. Half a volt may sound tiny, but it is everything, to us and to anyone who comes after. This discovery invites reflection. Our place in the cosmos is fragile and also wonderful. We rely on a delicate harmony that deserves to be celebrated and protected every single day. If you found yourself amazed by this journey, click and check out the next video. We'll explore how solar storms could threaten this subtle balance and what that really means for our planet's future. Look up, stay curious, and keep exploring. After all, the universe is spectacular when it finally starts to make sense. Did you already know about this electric field's role in protecting the Earth?